and let's jump right into the next generation data science workspace. And I'd like to start with some old news. If you're attending this conference, you probably don't need any more convincing. The data and AI trend has been transforming all industries for a couple of years now. Almost all major companies are realizing that these investments lead to competitive advantages. Now, if you ask me, I don't know what those remaining 12 Fortune 1000 companies are up to. And as a result, the job market has been playing catch-up to meet the demand. 3 out of the top 8 jobs in LinkedIn's latest emerging jobs report are data and AI roles. Congratulations to you if you're in any one of these categories. I'd say you have some pretty good job security ahead of you. Now, one thing you will notice is that there's a diversity of roles needed to deliver on these strategic initiatives. It's not just one abstract data and AI engineer. Solving the world's toughest problems really is a team sport. And you need all of these functions working together as a team and not in isolation. Of course, at Databricks, we call this unified data analytics, and we've built a platform for that. Collaborative data science workspace becomes the focal point of such a platform. It needs to cater to all of these users' needs and bring them together. Today, I'm going to introduce you to the next generation of our data science workspace, an open and unified experience for modern data teams. But before we do that, let's look at where we're coming from. And we've already come a long way in simplifying data and AI to help data teams innovate faster. On the left here, you can see a MapReduce program to count words. You should probably remember this just in case it ever comes up in an interview. Of course, writing this code snippet is just the first step. Back when this was still cutting edge, you would still have to worry about setting up a cluster, writing a couple of more lines of configuration, and hope you get it all right. Thankfully, today, you don't have to worry about any of this. In Databricks, you just write a Spark SQL query and hit run. The cluster in the background autoscales for you, and you just sit back and wait for the result. Now, of course, this is a very simple example, but it extrapolates to the full complexity of data engineering at scale. But as mentioned, this is only part of the solution. Where are we when it comes to data science today? When it comes to productionizing data science projects today, we're still dealing with a big mess. If you've ever tried to do statistical data analysis, or maybe train a machine learning model, you know that the tools that are supposed to make your life easier are still very difficult to use. In fact, according to one study, only about 15% of those Fortune 1000 companies have deployed AI capabilities into widespread production. The reason, of course, is that the tools available to these companies, specifically in enterprise software, haven't kept up with new emerging practices in data science and machine learning. And as a result, we are made to choose between 3 bad options that are all not that great. The first, and for many the most natural option, is to just give everyone the freedom to do whatever they want on their laptop. Of course, data scientists love that. You have full freedom to install anything you need, and you can move fast. However, you're pretty far away from your data. You'll need to downsample and copy data onto your laptop. And of course, you don't have to sit in compliance to know that moving sensitive data onto your laptop is generally a bad idea. And the folks who are maintaining your production systems are definitely not going to be happy to try to reproduce your local environment. To address some of these concerns, some vendors take the approach to just put those same tools you use on your laptop into the cloud. Essentially, they're giving you a virtual laptop. Now, however, just hosting Jupyter and giving you a VM with scikit-learn or TensorFlow pre-installed isn't that much of an improvement. Sure, you no longer have to copy data onto your laptop, but aside from security and governance, there are no obvious benefits, just more constraints. And finally, you may be asking yourself the question, why not iterate on our production infrastructure directly? Well, unfortunately, those production-hardened systems are not really ideal for exploration. And most data scientists will not be happy if you try to teach them Kubernetes. So you're left with a hard choice: full freedom of a laptop, slightly worse experience with the same tools in the cloud, or a fully production-hardened system that no data scientist will want to use. Thankfully, we're in the 21st century, and with a little customer obsession and engineering, we've been able to navigate these trade-offs. Our solution for modern data teams starts with the premise that developer environments need to be open and collaborative. Our workspace follows open source standards and provides a collaborative notebook environment on a secure and scalable platform. Next, the industry has already figured out best practices for versioning and CI/CD, and they're Git-based. So we integrate our platform with this ecosystem and provide those best practices to data engineering and data science, where reproducibility is becoming more and more important. Finally, to reduce the time from experimentation to production, the same environment can be scaled to production deployments, allowing you to manage the full lifecycle within one platform. And bringing all of this together, I'm extremely excited to announce the next generation data science workspace on Databricks. And without further ado, let me walk you through some of these innovations step by step before we give you a demo. This is a screenshot of the current workspace navigation in Databricks. It brings together all of the components you need for collaborative data science: notebooks, clusters, jobs, models, and access to all of your data at any scale. For those of you who are familiar with this interface, you may notice something different. We're introducing a new concept called projects to the left navigation panel. One of the most common ways that data scientists start their work is to clone a Git-based repository. With projects, you can bring all of your work to Databricks, where you can access all of your data and use best-of-breed open source tools in a secure and scalable environment. Because projects are Git-based, you can keep them in sync by pushing and pulling changes. Of course, you can also switch between branches or create new ones. This basic functionality provides you with a powerful set of capabilities to integrate your Databricks workflows with your CI/CD automation. And it enables you to follow best practices when you move from experimentation to production. And you don't have to learn DevOps tools. Now, many of our customers have been waiting for this projects feature, and I'm happy to announce that it is available in preview today. Now, we have many more exciting features coming, and I'll give you a quick sneak peek of those as well. At the intersection of Git-based projects and environment management is the ability to store your environment configuration alongside your code. This integration will allow us to automatically detect and enable your environment, removing the need for you to worry about installing library dependencies yourself. And you know, sometimes saying it just works is the most powerful statement. And in this case, we make it just work. Following the same behavior you're used to on your laptop, we give you an environment that matches your environment specification and make it available consistently on all workers on an autoscaling cluster. So now that your environment is all set up, let's look at your code. You can already import IPython notebooks to Databricks. This allows you to convert your Jupyter notebooks to Databricks notebooks and vice versa. In the future, we will store these notebooks in their native format, removing the need for conversion. This not only makes Databricks more standards compliant, but it also enables us to support alternative editors. So if you want to, we allow you to open these notebooks in Jupyter right here in Databricks. And similarly, by the way, for the R users among you, we also support RStudio. However, as mentioned earlier, just providing you with cloud-hosted open source tools is not quite good enough. So by default, we will open these notebooks with the Databricks Notebook Editor. The Databricks Notebook Editor can open Jupyter notebooks and in addition provide you with collaborative features like co-presence, as indicated in the top right of the screen, and real-time co-editing, as indicated by a colored cursor. And to facilitate collaboration even more, Databricks notebooks also allow you to comment and leave comments for your colleagues, all in one cloud-based environment. Now, by allowing you to open Jupyter notebooks in the Databricks Notebook Editor, you will no longer have to make the trade-off between using standard formats and the collaborative features and benefits that Databricks provides. So in summary, this is our solution for modern data teams. I showed you how we provide collaborative notebooks based on open standards, integrate with the Git ecosystem for collaboration and reproducibility, and provide integrations with CI/CD systems for a robust workflow from experimentation to production, all on a secure and scalable cloud platform. But you don't just have to take my word for it. So let me introduce Laura and Richie, who's going to give you a demo.
Thanks, Clemens, for the introduction. Let's jump right into the demo. For the purposes of this demo, imagine I work at a big retail company. We used to do our forecasts on a quarterly basis. It's a big effort for our data scientists to come up with those forecasts using many different tools. And once that is done, we print them to PDFs and send them out by email. That has led to lags in decision-making because we use outdated forecasts. Of course, these days, the world is changing at a rapid pace, and our leadership team has asked us to move from a quarterly to a weekly basis. That will significantly improve the quality of our business decisions, like how much inventory to order. The amount of manual work involved in producing this forecast is prohibitive in doing this more frequently. So, as a good data scientist, I am determined to automate this process and provide our decision makers with an interactive dashboard that always has the latest forecasts ready. First, I'm wondering if there's a better tool for those forecasts. So I searched Google for Python forecast libraries because I know that there's a lot of innovation. And I find this library called Profit, which was open sourced by Facebook. I read about it online and heard good things, so I'll check it out. Of course, there's a lot of toy examples available online. So I found one and forked it into my GitHub account here. As you can see, it comes with a dataset and a Jupyter notebook that shows you how to create a forecast. This is great. Usually, the way I go about this is to take an example like this and try to recreate it just to make sure it's not outdated. So I click clone to get the repo URL because I'll need it in a minute. So here I am in my Databricks environment, which we call the Workspace. In the past, it would have been pretty difficult to get code from a Git repository into Databricks. However, as Clemens mentioned, we now have this new feature called Projects, which allows you to easily clone a Git repository. When you click Create Project, you provide the path to a Git repository. So I just paste the URL that I just copied earlier into this text box. When you click Create, we clone this repository and make it available in your user folder. As you can see, it indicates which branch you're on. And when you click into the project, you see that all of the files were cloned. So the first thing that I'll do is to create a branch, because I don't want to mess around with the master branch because that will be used to run our production job. I open the Git dialog and I can just start typing a branch name into this text field. Now I click on Create Branch from Master and I'm ready to go. As you can tell, we're trying to make the most common workflows super easy without having to leave this environment. Now that I'm in my feature branch, I'll click on the Jupyter Notebook and you'll see that we open it in the Databricks Notebook editor. In addition to supporting standard formats, this editor gives you several collaborative features that we'll highlight as part of this demo. So let's get started. Databricks provides you with a scalable compute backend. I can attach a notebook to an existing cluster or create a new cluster. Let me attach this notebook to this cluster called ML cluster that's already running. Now, usually I would have to worry about the environment that is set up on this cluster and the libraries that are installed. But with the integration of the projects feature and our runtime that's running on this cluster, you will see that we automatically detect the presence of this requirements.txt. And as soon as I run any cell in this notebook, the cluster will make sure that the environment matches those requirements. So what's happening now is that Prophet is being installed in the background. We already pre-install many popular libraries like Pandas and NumPy, and we adjust their versions if needed. So let's just run this entire notebook and see if it works. As you can see, this reads in the CSV file from the data folder and loads it into a Pandas data frame. The file has two columns, one for date and one for the historic values of the column that we will try to forecast. In this plot, you'll see that we have data up until 2016, and then we forecast for another year after that. This is great because that's usually how you get started. Find an example and make sure that it works. However, this is just using toy data, and we have lots more data on our actual stores. So let's see if we can adjust this example to actually scale to our needs. I don't actually know where our sales data lives, so I leave a comment to ask my colleague to help me out here. Okay, let's see if he's online. Great, coincidentally, it looks like he's online and ready to help. You can see he opened up the notebook from the indicator up here, which shows which users are present in the notebook. Okay, looks like he responded. And he created a cell, so I'll assume he'll just share some code. Okay, great, he's actually using Koalas. Koalas is an open source library developed by Databricks that provides the exact same APIs, but uses Spark in the backend to scale computation. This way, I won't have to change any of the other code. The data frame is still named DF, and it should just work. So if I run this cell, you'll see that we're running a Spark job in the background and hand you back a data frame. This is now different from the toy example before. We have an additional column that indicates the store this data is from. In this case, we only have 3 for now: San Francisco, Amsterdam, and New York. Of course, I don't want to generate a forecast across all stores, but I want to have a forecast for each store individually. So instead of just running all of this through one big forecast, I group the data frame by store ID and apply the forecast as a UDF. What will happen is that we'll run a Spark job, group the data frame, and then for each store, we'll run this forecast. And I can also delete all of the other cells because we won't need them. Now, the only thing missing is that I want to write the forecast out to a Delta table to actually use it in my dashboard. I don't just want to run the forecast every time someone wants to look at it. So I add this code snippet that takes the forecast and stores today's date and the store ID so that I can query by that later. When I hit run, we'll bring up some Spark jobs in the background that crunch through those data and write out my predictions. Now this is great. I just cloned an example I found online, Databricks configured the environment for me, and I could easily change it all to scale all of my data by using koalas and writing out forecasts to Delta. Now, as mentioned earlier, if for whatever reason you want to use Jupyter, you can right-click on this notebook to open it with Jupyter right here in Databricks. Unfortunately, the collaborative features you just saw are not available in Jupyter. As a side note, of course, you could go back and forth between the two editors whenever you want. Okay, let's go back to the Databricks notebook editor. Of course, I've been working off of my feature branch here, so now I can go and check that code into Git. I open the Git dialog, provide a commit summary, and click Commit and Push. We won't show this in the demo, but usually you would go through the typical CI/CD workflow to create a PR, get it reviewed, and merge it into master. And here we set up our Git automation to automatically check out the master branch of this repo in this production folder whenever a new PR gets merged. From here, I can just open up the notebook. Now this is the master branch version that I want to automatically run. You can click on this calendar icon, which allows you to schedule this notebook as a Databricks job. Let's configure it to once a week, and this way I'll automatically get the new forecasts written into my Delta table. I'll click OK, and we're done here. Now this is a full end-to-end life cycle of experimenting with code in my own feature branch, checking it into Git, and pulling the master version into a production folder that is used to run a scheduled job. Let's quickly take a look at the dashboard that I put together. In this notebook, you can see that I use a feature of Databricks notebooks called Notebook Widgets. I can just create 2 widgets that give me the fields available in the Delta table. Those widgets will update whenever I get new data. And then the data that is shown is automatically filtered by my selection. I can create a dashboard from this notebook that embeds the table and visualization and also integrates the widgets to control the parameters of the SQL query. So when I click Present, you will see that the version of this dashboard that I'll share with our decision makers. Here they can select which forecast they want to see for which store, all updated and without having to write any code. And that's it for the demo. So just to summarize, in this demo, I showed you our support for the native Jupyter format and how the Databricks Notebook Editor provides collaborative features like co-presence, co-editing, and commenting. We saw the project-based Git integration and how easy it was to start by cloning a Git repository and creating a new branch for development. And finally, we productionized the forecast by pulling the master branch into a production project, scheduling a job, and creating a notebook dashboard to share the latest results with our business stakeholders. Now, in theory, I could even update these forecasts every day, simply by scheduling the production job to run daily. That's a massive improvement from the quarterly cadence that we were used to. And with this, I'll hand it back to Clemens.
Thank you, Lauren, for this amazing demo. I hope that everyone watching is as excited about the next generation data workspace as we are. To learn more, check out Databricks.com.